Hello everyone. The problem that we're going to be solving today is longest balanced subarray 1. This was a part of the weekly contest 472 that was held today. And let us read the problem. You are given an integer array nums. A subarray is called balanced if the number of distinct even integers, focus on the word distinct, even numbers in the subarray is equal to the number of distinct odd numbers. Distinct even and distinct odd numbers. Return the length of longest subarray. A subarray is a continuous non-empty sequence of elements within an array. So we have the first example as 2, 5, 4, 3, and we need to find the number of elements in the subarray which has equal number of distinct even and distinct odd. So the answer here is 4. Let me explain. So this is our question and they have asked we need distinct odd numbers. Now what is a subarray? Let us understand that first. A subarray is a contiguous block of elements in an array. Like this and this put together, this is not a subarray. This is not a subarray. This is a subarray because they are contiguous, they are next to each other. This is a subarray. So now we need to find a subarray. That means we need to find a contiguous block of elements which has distinct number of odd and even elements which are equal. So basically, let us first see this. We have 2. What is 2? 2 is even, right? 2 is even. We have 5. 5 is odd. 4 is even. 3 is odd. So if we consider this as an entire subarray, an array can also be a subarray. So if we consider the entire thing as a subarray, we have equal number of even and equal number of odd. Both of them are equal. Hence we return 4, right? So this is basically what they're asking. There should be equal number of odd and even elements in the subarray that is selected. The next example, let's just take the last one. Last example is 1, 2, 3, 2. Okay. So 1, 2, 3, 2. Now, what should be our answer? We need to return the distinct numbers, right? We need to return the distinct number of elements. So we have 1. What is 1? 1 is odd. 1 is odd. 2 is even. 2 is even. 3 is odd. 2 is again even. 2 is again even, right? 2 is again even. Now here if you see this subarray has the given condition satisfied. That means it has 1 odd and 1 even. It has 1 odd and 1 even. But the length of that subarray is 3. I told you now to focus on the word distinct. That means the numbers should be different. Same number cannot be counted as different. So if we take this subarray into account, we have 1 even number and 1 odd number. And 1 is equal to 1 because our criteria, what is our, let's just first write down the criteria of the subarray. Criteria for acceptance. I know there is a C less here, but anyways, criteria for acceptance. First, number of odd elements, number of odd should be equal to number of even, but keep in mind distinct. We need distinct. That means same number cannot be counted as same number of elements, that is the same element cannot be counted multiple times. If I have 2 will only be counted as one element, right? And our second criteria is that it should be a subarray. And our third criteria is the distinct one, which I also included here, but let's just write it down. Distinct elements to be counted. Distinct elements to be counted. So, okay, this is a very simple problem if you see on the surface level. We need to check for all subarrays. This is the first thing that comes to my mind, and it should come to your mind also. So how will we do that? How will we do that? So we need something to keep a track of odd elements and even elements, right? We need a data structure. We need a data structure to keep a track of odd elements and even elements. And we also need a data structure which does not store duplicate values. We need no duplicates. We don't need duplicates, right? We do not need duplicates. What data structure does not store duplicates? Hash set, right? A set data structure does not store duplicates. It also gives us O of 1 operations, right? Constant time operations. So what would we do? We'll check for each subarray. How do we start checking for subarray? So we check this. This is a subarray. This is a subarray. Does it have equal number of odd and even elements? No. Okay. We check for this subarray. Does it have equal number of odd and even elements? Oh yes, it does. It does. So my answer becomes 2. Now we check for the next subarray. Now we check for next subarray. Next subarray. Does it have equal number of distinct odd and even elements? Yes, it does. So my answer gets upgraded to 3. Now we check again here. Does it have equal number of distinct? No, it does not, because there is just 1 even and 2 odds. So no, my answer still remains the same. Now we check here. Now we check this. Now we check this. Does this have equal number of odd and even? See, it has 1 odd, 2 odd, and it has 1 even and 2 even. So yes, this entire subarray also. So we update our answer from 3 to 5. Now let's say I check for this also. Now we exclude this and we check this. Basically we need to check for all subarrays, right? We need to check for all subarrays. So if I would have taken this as an example, so I would have first checked this, then I would have checked this, then I would have checked this, then I would have checked this, right? I would not have found any, I would have found here, my answer would have been 2, but then I have here, but I have subarrays remaining here also, right? No, by not including this one. So I will check here. I found my answer. My answer was incremented from 2 to 3 because this is 3. Then I check for this, then I check for this, then I checked for this, then again the same thing, I checked for this, and I checked for this also. So basically these are all the subarrays that are found. So if I write down the subarrays inside of this, 1, 1, 2, 1, 2, 3, 1, 2, 3, 2, then I have 2, 2, 3, 2, 3, 2, I have 3, 3, 2, and I have 2. These are all the subarrays that are found. So we need to check for all of these, right? Somewhere we will have that. Somewhere. So I hope you all understood the logic. We will keep one pointer as a start pointer. That means I am starting from here, and we will have an end pointer. That means I am ending here, right? Let's say my start is here and my end is here. That means I am counting this, this, and this in my subarray. Then my end moves forward. After my end is completed the array, I move my start pointer ahead in order to check for all the given subarrays, right? That is what we do. Things will be much clearer when we write the code down. I don't know what happened, but anyways, here, so let's start our code by declaring our answer is 0, because if there is nothing, then my answer would be 0. Now int n is equal to nums dot length. Now we start with for int start is equal to 0, start is less than n, start plus plus, start plus plus. Now what do we do? For int end is equal to start. Why? Okay, what just happened? Some loose connection. Anyways, so now what did our code say? Code say this, right? That means end is less than n and end plus plus. Right? Now what essentially are we doing there? We are keeping two pointers, a start pointer and an end pointer. Our start pointer starts from the start variable and goes till n. That means we are counting this as a subarray, then we are counting this as a subarray, then we are counting this as a subarray, then we are counting this as a subarray. Once this is done, we are incrementing start, we are counting this as a subarray, then we are counting this as a subarray, then we are counting this as a subarray, right? So that is what we are doing, right? So now we first need to declare even odd. Our set of integer odd is equal to new hash set, and we have even. So now if num set end mod 2 equal 0, even dot add num set end, else odd dot add num set end. What did we do? So let's just say our subarray right now is this. So basically this is my odd hash set, this is my even hash set, let's just say, and my start is here, and my end is here, right? So now if you see my while loop, the inner while loop, the end loop, it starts from the number itself. So when my start is here, its end will start from here, right? So it would put 2 in even, then it would go here, the end will go here, it would put 3 in odd, then it would move ahead, it would again put 2 here, but 2 is already here, so we then do this. Now after every iteration, do you notice that we need to check whether our answer is matching or not? So how do we do that? After every iteration, if my odd dot size is equal to even dot size, odd dot size is equal to even dot size, my answer will be math.max of answer and end minus start plus 1. What is end minus start plus 1? Start is 1, end is 2, 3. So 3 minus 1 plus 1 is 3. Basically it gives me the length of this. So we check here, and finally after we are done, we return our answer and we run, and there you go, this was accepted, and voila, my code was accepted. And essentially our video is done here, but I'll go and have a dry run for this example. I hope you've understood. So let's just dry run this example once. So 1 2 3 2. So first my start was here, so let's just say my start is equal to 0, my end is also equal to 0. This is gonna be incrementing one by one, and we have my odd bank and my even bank here, and my answer would be stored here. Okay, So first my start was at 0, my end was at 0. What do I have? 1. Where does my 1 go? My 1 goes inside odd. So 1 goes inside odd. Is my odd and even sets equal? No. So it just goes ahead, makes end as 1. We are considering this. We get a new even. Are they equal? In size? Yes, they are equal in size. So what happens? Now? Since they are equal in size, my answer was initially 0. It checks what is the length of this. Length of this is 2. My answer's maximum is 2. 0 and 2 ka max is what? 2. So my answer becomes 2, and then my end becomes 2. It considers this. I have one more inside my 3, inside odd as 3. Then it checks, is the size equal? No. It again increments end to 3. It checks for this. Again 2 is there in even already, so nothing will be added. Again, are these equal? No. Since the array, the end has reached the last element, this will break. This will get empty. My answer from this, when I started from this and counted all the subarrays, my answer I got was 2. But now my start increments by 1 and my end starts from start. So here I consider this, I add it into even, then I add it into even. Since size not equal, I check ahead, I add it in odd. Since size is equal and size is 2 and 2, answer and size ka maximum is the same, 2. So nothing happens. This again increases to 2. Oh no, it was already at 2. So increases at 3. It checks here, same length. Yes. Now max of size is 3 and answer is 2. Oh, I got a new maximum. So 3. Now since end has reached the end, I increment my start. Again, same thing. I clear this out. Same thing. I add 2. So I add 3 here. Are these equal? No. So I do not check for answer. Now again, I consider this because this changed to 3. Then I added 2 here. Again, are these size equal? Yes. Answer ka max 3, 3, 2 ka maximum is what? 3. So my answer remains 3. Nothing happens here. Then again my end has reached the end. So again I increment my start. Now just this. My even is 2. Since the number of odd and even are not equal, I will increment, but there is nowhere to go now. So hence both my loops are terminated and this answer was returned. There you go. That is my problem. And that's it. Thank you so much for watching. I hope you all understood.